Hi, so today we are going to learn about prime factorization. And our learning target, I can find the prime factorization of a number. And we have touched on this in an earlier indicator when we had done GCF and LCM. And again, that is a part of this lesson also. So I just want to go more in depth into prime factorization. And the vocabulary that we are going to be learning are prime numbers and composite numbers. Okay, so let's look at prime numbers and composite numbers. So prime numbers are numbers that are divisible only by itself or one. So only when I multiply, or the opposite of division, divisible, it would be multiplication. So only if I multiply one times that number, I get that number. So those are prime numbers. Okay, whereas composite numbers, we can multiply a couple of whole numbers, not just one or itself, but several whole numbers, or another set rather than just one and itself, for me to get a composite number. So let's do some examples. So for prime numbers, as I said, it's a whole number above one that cannot be made by multiplying other whole numbers, right? So if I give you, let's talk about numbers. So we start with example. I have two, I have three, and over here I'm going to write four. I have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, etc. Okay, so this carries on. Now, if I look at this, prime numbers, as I can see, these numbers are prime. What I've written on the top, the prime numbers, because they are only divisible by two numbers. That is the number itself or by one. So 2 is divisible only by 2 or 1. 3 is divisible only by 3 or 1. 5 is divisible only by 5 or 1. 19 is divisible only by 19 or 1. Okay, but look at composite numbers. Not only is this divisible by 4 and 1, we can also do what? 2 times 2. So not just 1 times 4, but 2 times 2. That gives me a composite number. So it's more than just, two numbers. Let's look at 8. In 8, I can do 1 times 8. I can do 2 times 4. All right. So as you can see, that as we carry on, we keep getting, numbers. Look at 16. I can do 1 times 16. I can do 4 times 4. So, all of these, it carries on. I can do 2 times 8. So as you can see, that's the difference between prime and composite numbers. Okay, so we are now going to talk about prime factorization. And prime factorization is also called the complete factorization of a composite number, and it is a way of expressing the composite number as a product of its prime numbers. So product of its prime numbers. Okay, so we are going to completely break it down to the prime numbers that it is comprised of. Okay, so let's look at some of these numbers, and we are going to break it down. There are two different ways that we can actually do prime factorization. Okay, one is by using the factor tree, and the other is by using the division method. Okay, so factor tree or the division method. Okay, so I'm going to start with the factor tree first. I'm going to start with the factor tree first. And factor trees are a way of expressing the factors of a number, specifically the prime factorization of a number. And each branch in the tree is split into factors. Once the factor at the end of the branch is a prime number, only one pair of factors, the number itself and one, that's what a prime number is, the branch stops and you circle the number. And factor trees include whole numbers. However, since 1 is not a prime number, it will not appear in any factor tree. And to complete any factor tree, it is helpful to remember the prime numbers from 1 through 20. And see, I've listed those over here. Okay, so let's start with 120. Now, there are several ways to do this, but I know my divisibility rules, which I've done before. So I know that if it's ending in a zero, it's going to be something times zero, right? So it's going to be divisible by 10. So if I look at 120, I know that's going to be 12 times 10 because that gives me 120. So I'm going to start branching it out now. So let's look at this. I'm going to do 12 times 10. Now, when I look at 12 and 10, are they prime numbers or are they composite numbers? As we can see, look, 10 and 12 are both composite numbers because they can be further broken down into more numbers, okay? So if I look at 12, okay, I can do 4 times 3. 4 times 3. Let's look at 4. Is 4 prime or is 4 composite? 4 is a composite number. Look at 3. Is 3 a prime number? Yes, it is. So I am going to circle the 3 because that's as far as it can go. All right. Let's look at 10 now. For 10, I have, I can do 2 times 5. Right? So 2 times 5. Now, is 2 a prime number? Absolutely. Okay. Is 5 a prime number? Yes. So I'm going to circle these. Now what's left is 4. Is 4 a prime number? Absolutely not, because 1 times 4 and we have 2 times 2. So that's a composite number. So I'm going to break it down even further. So this I'm going to do 2 times 2 gives me 4. So now I can see these are my prime numbers. So as you can see over here, we keep going all the way till I get to all the prime numbers over here. And then it is a product of the prime numbers. So if I have to sit and talk about what is the prime factorization of this, let's start with the smallest. We have 3 2's, right? So for 120, I'm going to go ahead and erase this. Okay. You would rewrite 120 as 2 times 2 times 2 times 3 times 5. It's good to begin with the smallest and go to the largest. Okay? So think of it. What is 2 times 2? 4 times 2 is 8, right? And so that way we go 8 times 3, 24. 24 times 5, 120. So it's literally when you multiply the prime numbers, you get back to this number that you began with. But this is the product of its prime numbers. Now 2 times 2 times 2 can also be, because 2 is repeated 3 times, my base number is 2. I can write it as an exponent, 2 cubed times 3 times 5. And this would actually be my prime factorization of 120. And that's how we write it, okay? So let's do another one using a factor tree. And I am going to use the factor tree method first. So let's look at 48. I know that 48 is an even number because based on divisibility rules, it will definitely be divisible by 2. But there are other ways. I mean, it doesn't matter what you begin with. At the bottom, you will end up with exactly same prime numbers, okay? So I can do 2 times 24 right? Or I can do 8 times 6. Whichever method you use, you will still end up with exactly the same prime numbers at the bottom. Okay, so if I have 8 times 6, we know 8 and 6 are both composite numbers. So for 8, I can do 2 times 4. And for 6, I can do 2 times 3. Now, over here, what do I see? I can see that 2 is prime, 2 is prime, 3 is prime. And then I have 4 left, which is still a composite number, and that would be 2 and 2, because 2 times 2 gives me 4. And now when I look at, so this one over here, this is my 120, is this. And so for 48, I have 1, 2, 3, 4 twos. 1, 2, 3, 4 twos, and 1, 3. So that is my prime factorization. This can also be written as 2 to the fourth power, 1, 2, 3, 4 times 3. So that is the prime factorization of 48. 2 times 2, 4 times 2, 8 times 2, 16 times 3, 48. All right. So let's do another problem. Let's do 850. Now, there are several ways of doing 850. I can do, because it's ending with a 0, I can definitely do 85 times 10. But I know, looking at that, there are other ways of doing this also. I can do 25 times 34. That will also give me exactly the same thing. Okay, so now let's look at 25 and look at 34. Are these both prime numbers or are these composite numbers? Okay, so I can see 25. It's not just 1 times 25. I can also get 5 times 5, which is 25. Okay, so this is a composite number, and I'm going to break it down, and I get 5 and 5. So I know that 5 is prime and 5 is prime. And for 34, I can get 2 times 17. 2 is prime. I also know that 17 is prime. Okay, so for the prime factorization of 850, I would get 2 times 5 times 5 times 17. Okay, and then that way, because think of this, 5 times 17 is 85, and 2 times 5 is 10, and 10 times 85 gives me 850. So same thing. All right, now I can rewrite this as 2 times 5 squared, because 5 times 5 times 17. So this is how we do prime factorization using the factor tree. All right, now I'm going to show you a prime factorization of a number using factor tree and the division method. So I'm going to erase this, and I'm going to use the number 60. I'm going to use the number 60. All right, so the factor tree method first. So if I have 60, let's look at this. All right, so I know again this is ending in a 0. This is not a prime number, it's a composite number. So I know that 6 times 10 is going to give me 60. All right, then I look at 6. 6 is still a composite number because 2 times 3 is also going to give me 6. So I'm going to break this down further, and I get 2 times 3, and both of these are prime numbers, so I'm going to circle them. Then let's look at 10. 10 is also a composite number. So I'm going to break this down further, and I get 2 times 5, which gives me 10. So think of it, 2 times 5 is 10, 2 times 3 is 6, 6 times 10 is 60. So this is how we are breaking it down using a factor tree. And if I was going to do the prime factorization of 60, I would do 2 times 2 times 3 times 5, which can also be rewritten as 2 squared times 3 times 5. So this is using a factor tree method. Now let's do the prime factorization using the division method. Okay, so let's look at 60 and we are going to start now dividing. Okay, so 60, I know this is an even number, so it is divisible by 2 because we know our divisibility rules. So if I divide by 2, I get 30. Looking at 30, it is also an even number, so this is again divisible by 2, and I get what? I get 15. Okay, so now look at 15. This is not an even number, but I know my divisibility rule of 3. For the divisibility rule of 3, if I add up the digits, it should be divisible by 3. So what is 1 plus 5? 1 plus 5 is 6. So I know 6 is divisible by 3. So I know 15 is going to be divisible by 3. So I am going to divide this by 3 and I get 5. Then I look at 5. 5 is divisible only by itself. Okay, so I am going to do by 5 and I get 1. So now look, based on this, my prime factorization using this is the division method. 2 times 2, 4 times 3, and which is 12 times 5, which is 60. So it's the same thing what I just did here, but now it's written on the side. And so here, same thing, 60. I have 2 times 2 times 3 times 5, which is 2 squared times 3 times 5. So it doesn't matter which method you use, whether you use the factor tree method or you use the division method, you will still end up with the exact same prime factorization. Okay. Let's try another example of the division method. Okay, so let's do another one with the division method. Or I can show you both actually. We show you factor tree and division. Okay, so let me take the number as 40. So if I look at this once again, 40, I have a 0 at the end. So I know that 4 times 10 gives me 40. 4 can be further divided into 2 times 2. So these are prime numbers, and 10 can be divided out further into 2 times 5. Okay, so now when I look at this, I have for 40, my prime factorized numbers are 2 times 2 times 2 times 5, which is also 2 cubed times 5. All right, so that is the factor tree method. For the division method, I'm again going to start dividing 40. I know that 40 is an even number, so I am going to divide by 2. So if I divide by 2, I get 20. I know 20 is also an even number, so it's again divisible by 2, and I'm going to get 10. Then I look at 10, that's still an even number, so it is divisible by 2. I'm going to get 5. And then 5 is divisible only by itself, so I'm going to get 1. So look again, same thing. I will get for 40, the division method, I'm going to get 2 times 2 times 2 times 5, which is 2 cubed times 5. So no matter which method you're following, you will end up with exactly the same answer. All right, so let's try another one with the division method. Okay, so I'm using division method now. Here, division method. Okay, so let's say I ask you to find the prime factors of 1240. Looking at that, again, I know that it's an even number. So I start dividing by 2 because I know that 2 is the smallest prime number and the only even prime number that we have. Okay. So 1240, and I get 6 times 2. 2 times 2 is 4 and 0. 620. Now, again, with that 0 at the end, it is again an even number. So I go to 2 again and I get 3 times 2, 1 times 310. Again, divide by 2. All right. So then when I'm dividing by 2, I'm going to get 1 times 2. 5 times 2 is 10. And then I get another 5 times 2 is 10. Okay. Now, let's look at this. And I know that this is not divisible by 2 anymore, and because it's not an even number. Let's try the divisibility rule for 3 because that's the next prime number that we have. What is 5 plus 5, which is 10, plus 1, 11? Is 11 divisible by 3? No. So this number is not going to be divisible by 3. So then 4, that won't work because that's a composite number. What's the next one? We know that it's ending in a 5. So the next number that prime number it's going to be divisible by would be 5. Okay, so we are going to put 5 over here because anything that ends in a 5 or a 0 is going to be divisible by that. Okay, so if I divide 155 by 5, I know that 3 times 5 is 15 and 1 times 5 is 5. Okay, now let's look at 31. 31, it's not ending in and even it's not an even number. It's not ending in 0 2 4 6 8. All right. The divisibility rule for 3 doesn't work because 3 plus 1 is 4. Okay, and 4 is not divisible by 3, does not end in a 5, does not end in a 0, so it's not divisible by those. Okay, the rule for 4, the last two digits should be divisible by 4, and in this case it is not. The rule for 6, it should be divisible by both 2 and 3 to be divisible by 6, and that's not the case in this. 9 has the same rule as 3. So you add up the digits, which is 3 plus 1, that is 4, and 4 is not divisible by 9. So when I'm looking at this, and if you know your prime numbers, 31 is a prime number. So ultimately, what do? I have to divide by 31 because prime numbers are only divisible by 1 or itself. So when I divide 31 by 31, I get 1 now finally. Okay, so if I am finding the division method of this for 1240, this is going to be 1 2 3. I have 3 2, so 2 cubed. 2 times 2 times 2 is 2 cubed, all right, times 5 times 31. And that is the product of my prime numbers for this one. All right, so let's do one more problem using the division method. And that is 5. Let's use the number 544. 544. Okay, so if I start dividing, I know that this is an even number, so this is going to be divisible by 2. And when I divide by 2, I'm going to get 272. Now again, 2 at the end, so it's an even number. So this is going to be divisible by 2 again because it's an even number. Okay, so if I'm dividing by 2 again, right? And when I divide 272 by 2, I'm going to get 136. Since it's ending in a 6, it's still an even number. So I am going to divide further again by 2. And when I divide 136 by 2, I'm going to get 68, still ending in an 8. So that is an even number, again divisible by 2. And when I look at this, 68 divided by 2 is going to give me 34. Remember, whenever I'm saying divided by 2, it's basically half the number. Okay, so now again, let's look at this. Since it's ending in a 4, it is divisible by 2. And half of 34, or 34 divided by 2, is going to give me 17. When I look at 17, we know that 17 is a prime number. So that means 17 is only divisible by 1 or itself. So 17 divided by 17 is going to give me 1. So now I have all my prime numbers over here. How many 2's do I have? 1, 2, 3, 4, 5. So this would be 2 to the 5th power times 17, and that is my final answer of it being divisible down to my prime numbers. Okay. um, so what are the two different methods to find the prime factors of a number? Here are the two methods over here. You can do the factor tree method, or you can use the division method. You're breaking down a composite number to the product of its prime numbers. What if I say, what is the prime factorization of 13? Let's say I give you a question like that. Okay, so and I say, what is the prime factorization of 13? So because the prime factors of 13 are 1 and 13, and you know that 1 is not a prime number, but we know that prime numbers are divisible only by itself or 1. So it's 1 times 13 basically. All right. So therefore the prime factorization of 13 would just be 13. All right. So we have also talked about how to use prime factorization to find the GCF and LCM of a number. And for that, you will have to check out my next video, which will be immediately after this one. All right. Have a great day, you all.